In this video, we'll discuss accuracy and precision. Accuracy is how close the measurement is to the true value. Precision is how well can those measurements be replicated. And the ability to be replicated is dependent on the amount of uncertainty of the measurement. If you look at targets as an example, I think this illustrates it well. If you have an accurate measurement, you'll hit the bullseye. If you have a precise measurement, all of your shots will be clustered together because they're easily replicated. Notice over here we have high precision because it's replicated, but the accuracy is low because we did not hit the bullseye or even come close to the bullseye. Over here, it's low accuracy because we did not hit the bullseye, but it's low precision as well because the shots were not clustered. They were not easily replicated. Over here, low precision because we did not replicate the shots very well, but it's kind of accurate because we're close to the bullseye, and maybe because of the precision, we didn't hit the bullseye. But in terms of chemistry, this is the type of example that we'll look at. We're going to look at measurements. We're not going to look at targets. We're going to look at measurements. And so in this example, there are 4 different teams that are measuring the same thing. And each time you do one of these problems, it'll be a different fossil or object. In the first measurement, team A, 3.90 kilograms, but notice that's it, right? There's no plus or minus. On these two, you have plus or minus a certain amount, whether it's a mass or a percentage. In the second one, we have plus or minus a mass. Now this plus or minus, this is the amount of uncertainty. So this has to do with precision. The plus or minus something is your precision. Plus or minus percentage, that plus or minus value, that's precision. And look down here, this gives you a range. So the range tells you that you have, plus or minus a certain value, but it's not really stated like this. But if we think about the midpoint, then we have plus a certain amount and then minus a certain amount. So this example where you have no precision listed, we can say that we can assume that plus or minus 1 in the last significant digit of the measurement is your precision. So plus or minus 0.01. See, our last significant digit is that 0, so plus or minus 0.01. And B, plus or minus 0.05. Well, that one's easy. B gives it to you. That is your amount of uncertainty, 0.05 kilograms. In C, it doesn't give you kilograms, it gives you percentage. So we need to convert that percentage to kilograms. So you simply multiply 4.15 grams times 6%. That gives you 0.249 kilograms. And then right here, notice that my measurement, I didn't put in 4.9, I didn't put in 5.9. I split the difference. I found the midpoint. And so 5.4 kilograms plus 0.5 gives me 5.9. So that's my range. It's between 5.4 and 5.9, which is 0.5. Well, it's also minus 0.5, right? Because 5.4 minus 0.5 is 4.9. So that's your uncertainty right there. It gives you the uncertainty. You just have to format it in a way that it's similar to the other one so you can compare. Now remember, the most precise is what we're looking for. And the most precise measurement is the one with the least amount of uncertainty. And so if we look at these, Team A had the least amount of uncertainty. So Team A had the most precise measurement. Accuracy is significantly easier because all you have to do is look at the value. This is the true value for the measurement, 4.4. So how much do each of these deviate from 4.4? Well, This one deviates 0.5, this one deviates 1, this deviates 0.25, this one deviates 1. So the most accurate is Team C, 0.25 off of 4.4. So Team C was the most accurate. Team A was the most precise. All right, hopefully that helps.